Olutona Academy.
There, welcome to my channel Olutola Academy. In this video lesson, I will be working on the topic moment of force, and I will be solving some examples to show you how to calculate the moment of a given force. To start with, I give you a definition here. Moment of a force about a point or axis is the turning effect of the force about that point. And mathematically, we can write the moment of a force as force times the perpendicular distance of the pivot to the line of action of the force. The unit of moment is Newton meter because force is Newton and distance is meters. So we take note of this, and we are going to use this in a short while to solve. Now, examples of moment of a force. Moment of a force is seen in the turning on or off of a tap. When we turn on a tap, we are actually putting the principle of movement into work. Tightening a knot with a spanner is another example of moment of a force. Screwing a nail in and out of a wood with a screwdriver is another example. When riding a bicycle, the push we exert on the pedals with the feet produces a turning effect which causes the wheels to rotate. In opening a door, we put a force on the door handles which exerts a turning force about the hinges. These five are practical, real life, everyday examples of moment of a force. So we'll get to the examples in a short while. But before the examples, we are going to be using this principle to solve the examples, and the principle goes: principle of moment states that if a body is in equilibrium, let me mention before I go on that equilibrium is the principle of moment or moment of a force is a subtopic under equilibrium. So if a body is in equilibrium, then the sum of the clockwise movement about any point on the body is equal to the sum of the anti-clockwise movement about the same point. So this principle is important to what we are going to do here today. So let's get to the examples. The first example I have here is a uniform bar with weight 20 Newton rests on two supports P and Q as shown, and weight suspended as shown. Calculate the reaction at P and Q on the supports. So we are given the diagram. We don't have to draw a diagram here. So we are to find the reaction at this pivot, which is directed upwards. To start this example, I'm going to recall the first condition of equilibrium. And that condition goes total upward forces is equals to total downward forces. What that means is that the downward forces, as we can see here, 15, 20 and 5 must be equals to the reaction forces, which are let's call the first one here x, and let's call this y. So it means, according to this condition, it means x plus y is equals to 15 plus 20 plus 5, and that's x plus y equals to 40. So that's the first condition of equilibrium. Can label this to be my equation 1. So going on now, I will also need the second condition of equilibrium. And the second condition of equilibrium is the anticlockwise moment is equal to clockwise moment. So we have to find the moment now of each of these forces. We identify the anticlockwise, we identify the clockwise, then we equate them together so as to find the unknown, the reaction at P and Q, X and Y. So let me identify the anticlockwise and the clockwise moment. Now we have 5 forces here: 1, 2, 3, 4, 5. Now we have 2 upward forces. We have 1, 2, 3. They are downward forces. Now to find the moment now, I can either find the moment about this point, this pivot P, or this pivot Q. Either way, I'm going to have the same answer. So I'm going to taking moment about P. I would like to take a moment about P. So what I'll need to do is to reference, make all these the 5 forces have a turning effect about P. Now if I start with 15 Newton, it's going to have an anti-clockwise moment, meaning it's going to turn about this through this distance 3. So this will give us an anti-clockwise moment. Then 20 will give us 20 Newton will give us a clockwise moment, CW for clockwise, ACW for anti-clockwise. Then 5 Newton will give us also a clockwise, in the direction of a clock, a clockwise moment. Then this Y will give us an anti-clockwise moment, Why is giving us an anti-clockwise moment? Simply because I started with the downward forces and I took them as the reference. So since these are the reference forces, because I started with them, the downwards, so this will not give that clockwise, but rather anti-clockwise moment, because it's facing upwards. If it were to be facing downward, if Y had been facing downward, is a downward force, it's moment, but since it's facing upwards, it will give an anti-clockwise moment. Now, force P will not have a turning effect about P because it's directly on P. It has no line of action. There is no perpendicular distance of X on at about point P. So this is out. But if you are taking moment about Q, X is going to have a turning effect, while Y will not have a turning effect. So having identified the clockwise and the anti-clockwise moment, I put them in here now. So the anti-clockwise moment is 15 times the line of action, the perpendicular distance to P is 3. So that's 3. I close the bracket. Then since I have another force here, I have another anti-clockwise, that will be plus Y, the unknown, Y times that will be 3 to P. So 3 plus 2, that's 5. I close the bracket, equals to, so this is the anti-clockwise. Then I will go for the clockwise now. I'll go for the clockwise now. I have 20, and the line of action is 2. 20 times 2, I close the bracket, plus 5 to point P here, we have 2 plus 3, that's 5. 5 plus 2, that's 7. So 5 times 7. So let me go through it again so that you might follow me very well. The first, we are taking the second condition, and the second condition goes anti-clockwise moment equals to clockwise moment. So the first anti-clockwise moment here is 15, and the perpendicular distance to the point at which we are taking the moment is P. So 15 times 3, that's what is here. Then we have 15 times 3, yes. Then we have 20, no, sorry, we have Y times the distance here is 5 from here to this point is 5. Then we have equals to the clockwise now, 20 to P, that's 2. Then 5 to P, that is 7. 2 plus 3 plus 2 is 5. So what I have here, let me bring it down because of my picture, my video here. So times 3 plus Y plus times 5 equals to 20 times 2 plus 5 times 7. So this is the clockwise, and this is the anti-clockwise. So I can compute this now. I will have 45 plus 5y equals to 40. 20 times 2 plus 35. So I have 5y equals to 40 plus 35 minus 45. So I have 5y equals to 40 plus 35 will give me 75 minus 45, that will give me 30. So y is 30 divided by 5, and y is equals to 6 Newton. So that is the first reaction force. Now we are going to put y equals to 6. We are going to put that in equation 1 here, so that we can get x. So we have x plus y equals to 40. We have x equals to 40 minus y. We have x equals so we'll continue this example. So from here to here is 50, and from here to here is 75. So from here to here I have about 25 centimeter. I'm going to write 25 here now. 25 centimeter. That's 75 minus 50. 25. So it means the weight, which is unknown, to this point is 25 centimeter. Now from here to here is 50 centimeter, and from here to here is 10 centimeter. It implies that from here to this point is 40 centimeter. So having found the line of action, the distance from the pivot of the two forces or the two masses, we are going to now find the moment. And as we've done previously, anti-clockwise moment is equals to clockwise moment. So what that means is that this will give a turning effect in the anti-clockwise direction. Is anti-clockwise, then this will give a turning effect in the clockwise direction. So we have 50 grams. There's no need to convert this if you want your answer to be in grams, but if you want your answer to be in Newton, then you have to convert this by multiplying by 10. That's acceleration due to gravity. So we have 50 grams times, I'll take this off. Okay, 50 grams times the line of action, the perpendicular distance is 40, equals to the W, the force, times the distance, which is 25. We took moment about the pivot, taking I forgot to write that, taking moment about the pivot. So this we have 2000, 50 times 40, 2000 grams equals to 25 W. So I can divide both sides. I will have 2000 divided by 25 equals to 25 over 25W over 25. This takes this out. 5 here will give us 5. 5 here will give us 400. 5 here will give us 1. 5 here will give us 80. So it implies that our W is equals to 80 grams. That is the answer. So I go on next. I have